This video is for review quiz P.5, and this is all about factoring. Very, very important for this class. So this first part is just asking us to take out the greatest common factor. And the greatest common factor is just asking, what can you take out of both of these terms? What's the biggest thing you can take out of both? So for the numbers, we have 22 and 14. We can definitely take out a 2. That'll give us 11 and 7. And there's nothing else we can take out. We can also take out an x. Both of these have at least an x in it. That gives us 11x. And then from this one, we took out a 2, so this becomes 7. And we took out the x, so that goes away. And that's what we get. So you can ask the question, is there anything more I can take out in case you want to take it by parts? There's nothing else we can take out of here. 11 and 7 are both prime numbers. There's no common divisor. And you can also check your work to make sure you did it correctly. Distribute the 2x back into there. 2x times 11x. 2 times 11 is 22. X times x is x squared. 2 times 7 is 14. And the x is just there. And that is indeed the same thing. So this is the correct factorization for the greatest common factor. Always take out a greatest common factor if possible. It will make the numbers easier to work with because they're smaller. And that's correct. Okay, factoring by grouping is just kind of an extended use of this greatest common factor thing. But there's a couple steps to this process. The first thing is to ask, what can I take out of the first two terms? Not all of them, just the first two terms. And then what can I take out of the second two terms? So the first two terms, I can take out 2 x's. Both of them have at least 2 of them in there, so I can take out 2 of them. And this one has no number. Well, it has a 1, but no other number than that. So there's no number I can take out. That leaves me with a single x in the first spot, and then just a -3 here in the second, because I took out the x squared from it. Now from these terms, I can take out a 3. They both have a 3 in there, and because this is a plus, I'm going to write +3. If it's a minus, write -3. So I took out a +3 from this, that leaves me with just an x. I took out a +3 from this, that leaves me with a -3 there. And if you have the same thing in parentheses, then you've done it correctly. Now I can take out this green thing from both of these terms, and I'm left with what's on the outside, x squared +3. And that is how you factor by grouping. So there's really 2 steps. Take out the first thing, take out the second thing, and then take out this common term. If you don't have a common term, that means you did something incorrectly. So we have x -3, x squared +3. And that's good to go. All right, factor the difference of 2 squares. So there's 4 kind of formulas that you can use. That's a difference or sum of squares or cubes. For this one, for the sum of 2 squares, so it's going to be something like this: a squared plus b squared. This cannot factor. It's called prime. It can factor if you allow complex numbers, but we're not doing that here. Complex numbers tend to make things harder to work with, so we don't want to do that. So this is primes, meaning you can't. We don't want to factor it any further. A squared minus b squared, which is a difference of 2 squares, which is what this thing is. This is the same thing as a plus b, a minus b. And you can prove that for yourself if you use the AC method or any kind of factoring method. You can actually prove it's true. But this is so commonly used that it's good to have a formula because you're just going to use it a lot. This is a difference of 2 squares because we have a difference or a subtraction of 2 things, and the power on the variables that kind of hints at what it is, and this is a square. So we have 81x squared minus 100y squared. Now, all we have to do is figure out what is our a and what is our b. So the a is the first thing being squared. You could say it's x, but the 81 is a part of it. So we have to change the 81 into something being squared there. That's pretty easy to do because 81 is 9 squared. So I can rewrite this as 9 squared x squared, just like I can rewrite this one as 10 squared y squared. And this I can rewrite as 9x squared. And I can rewrite this one as 10y squared, because the power can distribute into the powers of the inside thing. And now we see directly that 9x equals a and 10y equals b. I can plug these things into our formula and we will have our factored form. So the factored form of this thing is just going to be a plus b, a minus b. And that is it factored completely. I didn't have to do anything else to it. I have the factored form right away. Once again, this is a special formula because these are so commonly used in mathematics. They show up a lot, but also they're nice to work with, and so people like to give problems with them in it. And that's correct. Okay, so just like when we had sum and difference of two squares, we have sum and difference of two cubes. You don't have to memorize the formulas for these. They're not terribly hard, but you don't need to. I mean, you just look it up. And the way this works is you a minus b, and then a squared plus ab plus b squared. This one's going to be a plus b, and then a squared minus ab plus b squared. You'll notice that negative become a negative there. Positive is a positive there. And the only thing that changes is this sign there. And that's because it's always the opposite of whatever the first sign is. You can kind of tell that. That's how I memorize it. And then of course, a squared plus, a squared, ab, b squared. That's because there's two things here, two things there, two things there. That's kind of how I memorize it, but you don't need to. Okay. This is a difference of two squares. X cubed, that kind of hints at a difference or a sum of two cubes. And this is a difference because we have a subtraction. So we're going to use this top formula. All we have to do now is figure out what is a and what is b. So 8x cubed minus 27. I can rewrite this as 2 cubed x cubed minus 3 cubed. And now we see we have 2x cubed minus 3 cubed. So a is 2x and b is 3. Just going to plug that into this formula and I'm good to go. So this thing is equal to a minus b, a squared, so 2x times 2x is going to be 4x squared, plus a times b, 2x times 3 is 6x, and then plus b squared. 3 times 3 is 9. And that is our factored form of this expression. Get it plugged in and see if it's correct. 2x minus 3, 4x squared plus 6x plus 9. Very good. Okay, I want to factor this polynomial completely. 3x to the fourth minus 48. Now, this is a difference, and you could kind of ask the question, is this a difference of it's not squared or cubed, it's to the fourth power, right? So it's going to be the difference of two fourth powers. But the first thing we can do here is we can take out a 3 from both of these. So let's take out the 3. If you can do this, do so. It's going to make your job probably pretty much easier. 48 is the same thing as 3 times 16, so it's going to be 16 here. And 16 is the same thing as 2 to the 4th power. And so now you see, yeah, it definitely is a difference of 2 4th powers. However, we do not have a formula for it like we do for the squares and cubes. We can, however, rewrite this as a difference of 2 squares. We can do that by doing x squared squared, because 2 to the power of 2 times the power of 2, 2 times 2 is 4, and 2 squared squared. So this gives us a difference of 2 squares, which we can use the formula I used already. We're going to have the first thing minus the second thing. We're just looking at these portions in parentheses. Then times the first thing plus the second thing. Now you'll notice that we have, once again, a difference of 2 squares and a sum of 2 squares. The sum of 2 squares will not factor at all, so I'm going to rewrite this as just 4, just to kind of make it nicer to work with or to see. However, this one, I can factor this even further. I can factor it into x minus 2, x plus 2, and then we have x squared plus 4. Now we are completely factored, and so this is where we can stop. So whenever you have a power of 4 here like this, really this is what you're trying to look for, to see if you can do this or not. If you can't do it, then you're fine, just leave it the way it is. But always check, and make sure you check again to see if you can factor it further. It always tends to do that, so keep that in mind. All right, let's check our work. X plus 2, x squared is 4. Correct. Very good. All we need to do here is factor it or state that it's prime. If it's prime, that means we can't factor it using our methods. If it isn't prime, then we need to do so and factor it. Always ask the question, can I take something out of all the terms? And I can. I can take out a 7. 42 times 6. And now this one is the AC method. I can use that to solve this guy. So I create a little diagram. We have A is, this is the same thing as 1x, so A is 1, B is -1, and C is -6. On top goes A times C, so 1 times -6 is -6. On bottom goes B, so it's -1. Two numbers that multiply to give -6 and add to give -1. That's going to be -3 and +2. That gives you -6 when you multiply, and yep, when you add them, it gives you the correct thing. Now, because A is 1 here, we can use the shortcut method. We don't have to do the full AC method. And it works out by having x minus 3, x minus or plus 2. That's the shortcut. It's very nice whenever A is 1, you can immediately do that. All you have to do is find these two numbers and you can plug them in there. You can always check your work by foiling it out and seeing if you get back to the same thing. So when you do that really quick, x times x is x squared, x times 2 is +2x, -3 times x is -3x, -3 times 2 is -6. +2 minus 3 is -x minus 6. And that is the same thing I had previously. So I did find it correctly, the factored form. So it is factorable, and it factors down to x minus 3, x plus 2. Correct. Last problem. Okay, this one's a little weird because we have variables in each slot, but we can still use our methods to solve this. First off, is there anything I can take out of each one of these terms? And there's not. 43, I'm pretty sure, is a prime number, so there's nothing I can take out of all of them. So I go straight to the AC method. I ask, what kind? So A is 7 here. B is negative 43. And C is 6. So A times C is 42. And B is negative 43. So two numbers that multiply to give the top and add to give the bottom. Those two numbers are going to be negative 42 and negative 1. Negative times negative will cancel, giving us positive 42, and they both subtract to give us negative 43. So this is the correct way. And A is not 1 here, so we have to do the full AC method. So we're going to bring down the first term, 7x squared. Then we're going to write negative 42. And then whatever the middle variable is, in this case is xy squared. Then negative 1, xy squared. Then 6y to the fourth. And now I can factor by grouping. That's the last step to the AC method, is factor by grouping. Out of the first two terms, I can take out a 7 and an x. So 7x. That leaves us with x minus 6y squared. I think that's correct. And then out of the second two terms, I'm going to take out a negative, because the first term is negative, a negative y squared. Take out a negative y squared, it's going to make this positive x. And then a negative y squared out of this makes this negative. Positive divided by negative is negative. 6y squared. And you'll see we have the same thing in parentheses. So we did it correctly. Write that thing down, x minus 6y squared. And the second term is going to be 7x minus y squared. That is the factored form of our polynomial. So we have x minus 6y squared, 7x minus y squared. Oops, that parentheses needs to go down in front. Hopefully this is correct, and it is.